Hey, how's it going? Did you know that one of the most famous dinosaurs of all time, the Triceratops, might not be exactly what you think it is? I know, it sounds crazy, but what if I told you it could just be the younger version of a dinosaur almost no one has heard of? The Torosaurus? This theory divided scientists, shook the field of paleontology, and made us question everything we thought we knew about these creatures. In this video, I'll take you right to the heart of this mystery. A journey where science, opinions, facts, and history all come together. Ready to uncover the truth behind this game-changing theory? Let's get started. Millions of years ago, during the late Cretaceous period, the world was a wild and unpredictable place. Across the vast plains that we now know as North America, amidst dense forests and abundant rivers, a giant emerged, one that would capture the imagination of the world millions of years later, the Triceratops. This impressive creature, first discovered in 1889 by Othniel Charles Marsh, wasn't just one of the largest herbivores of its time. It was also a symbol of resilience. The Triceratops could reach up to 30 feet in length and weigh an incredible 12 tons, about the size of 2 modern African elephants. But what truly set it apart was its head. Imagine a massive bony frill, so wide it could serve as protection against the attack of a hungry Tyrannosaurus rex. In front of this frill were 3 intimidating horns, completing the look of a true gladiator of prehistory. Paleontologists believe these horns, besides serving as deadly weapons against predators, had other purposes. During mating seasons, males likely fought each other to win over females, much like modern-day moose or rhinoceroses. These battles weren't just displays of brute strength, but also visual spectacles. Triceratops used their frills to impress and intimidate rivals, with scar marks serving as trophies of past battles. Despite its imposing appearance, the Triceratops was a peaceful herbivore. Its curved, sharp beak was perfect for ripping leaves, while its specialized teeth crushed tough vegetation. They roamed in herds, increasing their protection against predators. After all, if even a Tyrannosaurus rex might hesitate to attack a single Triceratops, imagine facing an entire group of them. This dinosaur wasn't just a survivor, it was one of the last great dinosaurs to live before the cataclysm that marked the end of the Mesozoic era. Living between 68 and 66 million years ago, it shared the final days of a dinosaur-dominated Earth. Its connection to the end of an era only adds to the fascination we have with it today. But the Triceratops didn't just survive its time, it thrived in humanity's memory. Since its discovery, it has become one of the most well-known and beloved dinosaurs. Films like Jurassic Park have portrayed it as a calm and majestic giant, while toys and documentaries have turned it into a cultural icon. Its name, meaning three-horned face, is recognized by millions of people around the world. However, behind all this fame, a mystery began to emerge. There was another dinosaur, the Torosaurus, whose similarities to the Triceratops were impossible to ignore. They shared the same territory, the same geological period, and characteristics so similar that some scientists began to wonder, were they really different species? While the Triceratops reigned as the most iconic herbivore of the late Cretaceous, another dinosaur, discovered just 2 years later, began to intrigue paleontologists, the Torosaurus. With a name meaning perforated lizard, a reference to the massive holes in its bony frill, it seemed like an alternate version of the Triceratops, albeit with some differences that made it even more fascinating. The Torosaurus shared the same habitat as the Triceratops, roaming the vast plains of North America around 66 million years ago. But one thing set it apart: its bony frill, which was significantly thinner, larger, and had 2 large openings in the middle. This feature raised many questions. Were these holes a way to reduce the weight of the frill? Or perhaps an evolutionary adaptation to regulate body temperature, similar to how elephant ears work today? While these questions are still debated, one thing is clear: the Torosaurus looked more mature in appearance, almost like an adult version of its cousin, the Triceratops. But it wasn't just the frill that distinguished the Torosaurus. Its skull was also slightly longer and narrower, giving it a distinct look. At about 30 feet in length and weighing up to 10 tons, it was similar in size to the Triceratops, which made their similarities even more intriguing. To complicate matters further, fossils of both dinosaurs were often found in the same rock layers, indicating they lived during the same time period and in the same regions. However, while the Triceratops became a symbol of the dinosaur era, the Torosaurus remained in the shadows. It never gained the same prominence in movies or pop culture and, for years, was treated as a separate but secondary species. It was almost like the forgotten sibling of the family, you know? But why was the Torosaurus less celebrated? The answer might lie in the fact that Torosaurus fossils are extremely rare compared to those of the Triceratops. Paleontologists have uncovered hundreds of Triceratops fossils over the years, but Torosaurus fossils are so scarce that each discovery is treated like a treasure. This rarity raised even more questions. Could it be that the Torosaurus wasn't a separate species, but rather a life stage of the Triceratops? This question began to gain traction in the 21st century. Paleontologists started to realize that the story of the Torosaurus might be closely linked to that of the Triceratops in ways no one had predicted. But before we dive into the scientific twist, let's explore how these discoveries shaped the debate. Enjoying this story so far? Then hit that subscribe button so you don't miss more of these mind-blowing stories that leave us wanting to know even more. Paleontology is a fascinating field, but it's also full of heated debates, especially when fossils challenge everything we thought we knew. And the case of the Triceratops and Torosaurus was no exception. From the beginning, the similarities between these two giants started raising intriguing questions. Were they truly separate species, or was there something much deeper behind their differences? This debate divided scientists for decades and, to this day, continues to fuel theories and discoveries. In the late 19th century, when the fossils of these dinosaurs first began to be unearthed, every bone was a mystery waiting to be solved. Triceratops fossils were found more frequently, while Torosaurus fossils appeared only sporadically. However, when both were discovered, their bones revealed nearly identical characteristics. Both had 3 horns, a curved beak, and a large bony frill on their heads. The main difference lay in the size and shape of the frill. The Torosaurus had a larger, thinner frill with large openings, while the Triceratops had a solid and more robust one. At first, these differences were enough for the two dinosaurs to be classified as distinct species. The Triceratops, with its solid frill, was interpreted as a more fortified creature, while the Torosaurus, with its frill openings, seemed to have evolved for lightness and perhaps even visual appeal during territorial or mating disputes. But the issue was more complicated than it seemed. When paleontologists analyzed fossils from both creatures, they noticed something curious. Torosaurus fossils always seemed to belong to adult individuals, while many Triceratops fossils were from younger ones. Did this suggest that the Torosaurus was simply an older, more mature version of the Triceratops? Or did they truly coexist as separate species, each playing its own role in the ecosystem? This divide created two main schools of thought in paleontology. On one side were the scientists who believed that the differences in the bony frill were too significant to be explained by age alone. To them, Triceratops and Torosaurus were close relatives, but distinct species. On the other side were paleontologists who began to question whether we were looking at the same animal, but at different stages of its life. This radical idea gained traction as new technologies allowed for more detailed analyses of fossilized bones. But, as with any scientific mystery, speculation wasn't enough. Concrete evidence was needed. This drove paleontologists to delve deeper into the internal structure of these creatures' bones. They hoped the answers lay hidden in growth marks, much like the rings of a tree, and in signs of aging within the bone tissue. This investigation set the stage for a groundbreaking revelation. Hey, if you're enjoying this prehistoric investigation, hit that like button. It really helps the channel grow and tells YouTube you're into content like this. Let's keep going. With the advancement of technology in the 21st century, paleontology gained new tools that allowed fossils to be studied with unprecedented precision. Scientists were no longer limited to analyzing the surface of bones. They could now examine their internal structure. It was within this context that, in 2010, a pair of scientists, John Scannella and Jack Horner, introduced a theory that would shake the dinosaur world. The Triceratops and the Torosaurus were not separate species, but rather the same animal at different stages of life. This groundbreaking idea was based on a detailed study of the bone structure of fossils. Using a method known as paleohistology, scientists analyzed thin sections of fossilized bones under a microscope. What they discovered was surprising. Triceratops bones showed signs of active growth, as if they were still in the process of developing, while Torosaurus bones were denser and exhibited characteristics typical of fully mature individuals. According to this theory, the Triceratops was actually the juvenile version of a dinosaur that, as it grew, transformed its solid frill into a lighter structure with openings that could have been used for display or temperature regulation. In other words, when the Triceratops reached adulthood, it became what we know as the Torosaurus. This dramatic change in the shape of the bony frill would be an extraordinary example of ontogenetic change, the process in which individuals change form as they grow. This hypothesis sparked a heated debate within the scientific community. On one hand, it made sense. After all, many modern animals undergo significant changes as they grow. Think, for instance, of the antlers of deer or the feathers of juvenile birds that change completely as they reach maturity. However, applying this concept to dinosaurs as large and iconic as the Triceratops and Torosaurus challenged decades of established thinking. The theory also provided an explanation for why Torosaurus fossils were so rare. They represented an advanced life stage of a dinosaur that was far more commonly found in its juvenile form as Triceratops. If this idea were true, it would mean that many museums around the world displayed fossils of what they believed to be two separate dinosaurs, but that in reality belonged to the same animal, just at different stages of growth. But not all paleontologists were convinced. Some argued that the differences in the size and shape of the frills between the Triceratops and the Torosaurus were too significant to be explained by age alone. They suggested that the analyses might have overlooked other factors, such as variations between populations or even genetic differences that could indicate separate species. The debate was far from over. In fact, it only seemed to be heating up as the scientific community searched for more evidence to support or refute this theory. And as the research continued, the idea that the Triceratops and the Torosaurus were two sides of the same coin began to captivate not only paleontologists but also the general public. But how can we be sure? This is where the crucial role of bones comes into play, revealing stories no fossil can hide. Let's dive into the next chapter to understand how paleohistology shed more light on this mystery. If fossils are the pieces of a prehistoric puzzle, paleohistology is the magnifying glass that allows scientists to examine those fragments with almost unimaginable detail. This revolutionary method, which analyzes the internal microstructure of fossilized bones, has become the key tool in attempting to solve the mystery of the Triceratops and Torosaurus. After all, if these two dinosaurs were simply different life stages of the same animal, the bones would be the first to tell the truth. Think of bones as diaries that record an animal's entire life story. When paleontologists examine ultra-thin sections of fossilized bones under a microscope, they can identify growth marks called lines of arrested growth, similar to tree rings. These lines reveal not only the animal's age but also its stage of development. In the case of the Triceratops and Torosaurus, differences in bone structure provided some of the strongest evidence supporting the theory that they were the same dinosaur. The bones of Triceratops showed evidence of active growth. There were layers of spongy bone tissue, which indicated that the animal was still developing, almost like a teenager. In contrast, the bones of Torosaurus were dense, with fewer visible growth lines, suggesting that these individuals had already reached full maturity. Additionally, the bony frill of the Torosaurus showed signs of remodeling, a process in which bone tissue restructures itself to adapt to changes in adulthood, such as structural support or reproductive functions. Another crucial clue came from the analysis of the holes in the frill of Torosaurus. These openings, which were one of its most striking features, were absent in young Triceratops. However, when paleontologists studied intermediate fossils, animals that were not as young as typical Triceratops but not as mature as Torosaurus, they found evidence of frills that were beginning to thin and develop openings. This suggested that the changes in the frill occurred gradually as the animal aged. But there was more. Paleohistology also revealed another fascinating detail. The tips of Triceratops' horns, which were rounded in younger individuals, became sharper in older specimens, such as those classified as Torosaurus. This further reinforced the idea that the two dinosaurs were connected, like different chapters of the same book. These discoveries were groundbreaking but also controversial. Critics of the theory argued that the differences in the shape of the frill and the presence of the holes were too significant to be attributed to growth alone. They suggested that factors like genetics or even environmental pressures might be behind these changes, and that perhaps these were two distinct species, albeit closely related. Even so, paleohistology brought something new to the table. Science now had tools to analyze fossils with an unprecedented level of detail. And as this technology continues to evolve, it promises to uncover even more secrets about dinosaurs and their complex stories. In any scientific field, bold theories inevitably face resistance, and the case of the Triceratops and Torosaurus was no exception. When John Scannella and Jack Horner presented their theory in 2010, suggesting that the Triceratops was merely the juvenile stage of the Torosaurus, the scientific community was divided. While many paleontologists saw merit in the idea, others completely rejected it, arguing that the differences between the two dinosaurs were too significant to be explained by aging alone. Critics of the theory pointed out several discrepancies. For example, while the frill of the Torosaurus was larger, thinner, and featured prominent holes, the frill of the Triceratops was thicker and completely solid. To some paleontologists, this indicated a fundamental difference in the structure and function of the frill between the two dinosaurs, suggesting they might have had different lifestyles despite their similarities. Perhaps the Torosaurus frill was designed for display and social interaction, while the Triceratops frill served as a defensive shield. Additionally, critics argued that the unique features of the Torosaurus could not be explained solely by age-related changes. They proposed that the Triceratops and Torosaurus were separate species that coexisted in the same environment but occupied slightly different ecological niches. In this scenario, the Triceratops might have been more common in areas with dense vegetation, while the Torosaurus perhaps preferred open regions where visual displays were more significant. Another point of contention was the number of fossils available. While hundreds of Triceratops specimens have been found over the years, Torosaurus fossils remain incredibly rare. Some paleontologists question this, stating that if the Torosaurus were merely a life stage of the Triceratops, we would expect to find more fossils showing clear transitions between the two. This lack of intermediate fossils remains a significant hurdle for supporters of the theory. However, the debates didn't remain confined to the academic world. For the general public, the Triceratops and Torosaurus were not just fossils. They were symbols of a bygone era, representations of grandeur and mystery that captivated the imagination of generations. Reclassifying the Triceratops as merely a juvenile stage of the Torosaurus seemed to diminish its identity as one of the most iconic dinosaurs ever discovered. After all, the Triceratops has always been a star, a central figure in books, movies, and toys, while the Torosaurus has remained largely unknown to the general public. This difference in cultural impact raised an important question. How did two such similar dinosaurs take such different paths in popular perception? It's a tricky thing to figure out, right? So now I want to know your opinion. Do you think the Triceratops and the Torosaurus were actually the same dinosaur at different stages of life, or were they completely separate species? Let us know in the comments. We'd love to hear what you think. Now, let's talk about why the Triceratops has always been so special. Since its discovery in the late 19th century, it quickly earned a place of prominence in both paleontology and popular culture. Depicted as a fearless herbivore capable of standing up to the mighty Tyrannosaurus Rex, its image became iconic in children's books, documentaries, and of course, in cinema. Films like Jurassic Park transformed the Triceratops into a true symbol of the dinosaur era. A calm yet imposing giant that captured the imagination of both children and adults. Its name was easy to remember, its appearance unmistakable, and its story full of drama. The Torosaurus, on the other hand, followed a different path, never achieving the same appeal or recognition in cultural productions. While the Triceratops dominated popular narratives, the Torosaurus remained an obscure figure, known only to specialists or more dedicated enthusiasts. For decades, it was considered a secondary dinosaur, almost forgotten among the giants that captured the spotlight. What makes this fascinating, however, is how science is rewriting this story. The possibility that the Torosaurus is actually the adult stage of the Triceratops reshapes how we interpret the past. This isn't just an academic debate, it's about how we build narratives about the prehistoric world. If this theory is true, then think about it. For decades, we've glorified a young dinosaur while completely overlooking its adult form, a powerful reminder of how science is constantly evolving. Even so, while the Triceratops continues to shine in the spotlight of fame, the mystery of the Torosaurus keeps intriguing scientists and challenging our understanding. These fossils, which have bridged science and imagination, remind us that the story of dinosaurs is far from being fully uncovered, and now we've arrived at the heart of this mystery. Are the Triceratops and the Torosaurus truly distinct dinosaurs, or are they simply the same creature at different stages of life? This story, full of discoveries and debates, reminds us that science is like the fossils it studies. It's never complete, but it's always evolving. Perhaps the Triceratops was a young dinosaur, strong and still developing, while the Torosaurus represented the maturity of an era that continues to fascinate us. Or maybe they were, in fact, separate species, showcasing the incredible diversity and complexity of life at the end of the Cretaceous. For now, the truth remains a mystery, but perhaps, in the near future, we'll finally uncover the answer. Who knows? What truly matters, however, isn't who they were individually, but what they teach us. Their fossils tell stories of struggle, adaptation, and resilience. Even 66 million years later, they challenge us to keep exploring and imagining. Science, like the story of the dinosaurs, is a puzzle that can only be solved piece by piece. Now, the decision is yours. After hearing all this, what's your theory? Were they just two stages of the same dinosaur? Or are we talking about entirely separate creatures? One day, science may give us the definitive answer. Until then, the mystery will continue to fuel our curiosity. Who knows what other secrets remain buried, waiting to be unearthed? And if you've made it this far, smash that like button and subscribe to the channel. Thanks for watching, and I'll see you in the next video.